So my presentation is about a journey, and it's a journey that SRC have been on, and in relation to design optimization using generative design tools. And where we have applied it at one of our colleges, our new build project, which is an RIBA Stage 2 project. So I suppose first of all, SRC is Southern Regional College, and we're one of 6 colleges in Northern Ireland, and we're halfway through a £100 million capital build project. So at this point in time as a client, we have experience of all the RIBA stages, including the facilities management, and then this is focused on the concept stage 2. And it is a sort of quite a technical subject. What I'm going to do is I'll first of all try and explain what generative design is, and then I'll talk about where we applied it, how we applied it, and then our lessons learned from it. So if you were to take, for example, a relatively small building of, say, 5,000 square meters, and you, as a designer, you were looking at that and saying, well, we know traditionally that could be 18, 19, 20, 21, 22 meters deep, and the site restrictions and planning restrictions allow us to go either 2, 3, 4, 5, or 6 floors. Then what you really have there is 25 options, design options potentially. And if you decide that you have a goal where you want to find the cheapest of those options, then there are a number of ways that you can go about that. For example, you could write that into Excel, because that effectively is, and I hope I don't see anybody walking out here, but it's mathematics. And what you really have there are 2 variables. You have a mathematical problem, you have a fixed constant, which is the 5,000 gross floor area, and then what you have is a dependent variable, which is the cost. So what you're trying to do is take a design approach which is data driven and mathematically driven. And as I say, you could do that in Excel, but what's available now is you have generative design tools such as Grasshopper or Dynamo and Revit, and what you can do is you can program those options into the computer. That's the programming on the left, and then it can generate the actual geometry so that you can see what the design might look at. Now, 25 designs is obviously not a large number, but in our project, whenever we were programming, we had 10,368 designs, so it shows how the numbers can quickly go up. In terms of the programming, that's called visual programming language. It's on the left, and it's Python for anybody who's involved in programming. And you tend to separate out into the geometry. So you create the geometry, and then you maybe create the actual goals. And then from that, the software creates studies. So you could say, I want to look at all 25 options, or maybe I only want to look at, say, 5 of the options using particular fixed. So you might say, I want to look at options that are all 4-story, or I want to look at all the options that are maybe of a particular building depth. And what it can also do is it can do generations. So what you would have is say, you create 3 generations. There's 3 design solutions initially in generation 1. You would look at whatever the cheapest or the lowest cost one was in that, and then you would keep that solution for the second generation, and then you create 2 more options from the software. And that might be just randomly, or it might be that you take the original lowest cost one and sort of vary it a wee bit. And the idea is that by working through a series of generations, you will then eventually find an optimized solution for whatever it is you're trying to optimize. Now, for us, where we applied that was we ran that idea in parallel during a live project and a real project, which was our Newry project. We had a new build on an adjacent site, which was beside an existing campus. We started it, it was part of an innovation clause in the contract where the architects, Macadam Design, would engage with us collaboratively to give us some of the figures that might be needed, and generally look at the process and get feedback from them as designers. My background, I'm the change manager for a BIM change manager with SRC, but I also have a background in design, so I'm aware that, for example, one of the ways you could analyze the design process is you could have your space planning, and then that would follow into form, and then you might follow that into your sort of fenestration. So it's the form follows function. If there's any architects in the audience. What we looked at was the form side of it. I know that there are studies around the space planning, but we focused on the form because we were looking at cost, the fabric cost, we were looking at energy from solar gains, we were looking at the visual impact. And the proof of concept was, we initially started off by building a model in the software, which was a proof of concept, just to see if we could do it and if it was working. And then we did an actual concept model that was based on the stage 2 design that the architects themselves had come up with. And then we had a data analysis and review process. And the three, although I showed an example there of cost as the thing that we were trying to optimize, in actual fact, a design is, and again in mathematical terms, is what's known as a complex problem. And in other words, it has a number of solutions, none of which you could sort of say are perfect. And design's very much that. So the three aspects that we looked at were the cost, and we used the new rules of measurement to calculate up the algorithms in the software, and we mapped it directly to the RIBA stage 2 reports and stage 1 report cost structure on the live project. We used the passive house calculations for the energy cost, the PHPP software, and then we deliberately chose visual impact because it's really the unmeasurable. And if you take, in any project, you have time, cost, and quality, it's relatively straightforward to measure your time and your cost, but measuring quality is a much more challenging thing, in particular architectural quality. So we wanted to pick something that was nearly unmeasurable, which is visual impact of a building. This is the first proof of concept study. So on the top left, what you'll see is the if you like, the red lines indicate the variables in the equations. So we're varying the depth of the building, the length of the building. And in this case, we didn't know what the final concept was going to be. We had assumed it might be a building linked to the existing campus. It would be an atrium, and we weren't sure if there would be a return on it or a projection out the front. So we kind of programmed the software to do both. And that allowed us to see if the idea behind it was going to work okay within the innovation. We then, during RIBA Stage 2, the architects themselves had come up with their concept, which was a 2-story building, and it allowed for a splay on the upper floor to improve the visual impact of the building, because that was important to the client. We wanted to establish ourselves within a sort of a college quarter within the city of Newry. And on the bottom left, you'll see, again, the variables in terms of the mathematics behind it, and the key sort of variables that were coded into the software. This is what the final concept model looked like in the software. You can see that it's relatively complicated looking, and the coding, and it's maybe not just for every client, but it breaks down into the creating of the geometry in one part of the code, and then creating the actual calculations in the other part of the code. This is then some of the tools that are available to you. At the bottom there, you'll see splatter plots, which you can start to analyze the information that comes out of it. And you can say, for example, you could put cost on the y-axis, you could put your energy cost on the x-axis, you could have the number of floors being the size of the circle, or you might have the location of the building being the color. So you start to be able to look at this more as a data analyst. And this, I call it a spider diagram in my head, but it's called parallel coordinates. And it kind of shows you the data in a particular way. Now, this is a very early study that we created in relation to cost. And on the bottom left, you'll see each one of these lines is a solution. So the blue line is saying there's a low cost solution, and if you move over to the number of floors, it's a high number of floors for that low cost. So when this initial study was carried out, what it was really saying was that there's a pattern, and that's what you're kind of looking for within the data. There's a pattern that the higher number of floors was actually producing a lower cost building. However, there were other things that were in those variables. For example, we were varying the percentage of glazing on a number of the facades. So we wanted to be able to know, well, was that impacting on the cost, or we were varying the depth of the building still. So in the second study, what we did was we took the percentage glazing variables out of the equation, and then what we did was we left the depth of the building still there. So what we can look at and see from this, and we took the energy out of it as well, So looking at this, we could able to see, well, we do have a low cost, we do have still the high number of floors, the higher floor number being relevant, and the depth of the building here varies. So there's that saying really that it's not having as much impact on the cost. So at this stage, it was sort of saying, if you build a higher tower block type building, it will reduce your costs. However, we did then have costs coming in from our RIBA stage 2, so we were able to calibrate, and there was a number of things came out of that. One was that our gross floor area wasn't allowing for voids, whereas the real design was. So we had to include that. We introduced a calibration factor, which was to allow for the fact that we were designing a relatively simple building and the other one was splayed, etc. So there was a wee bit of calibration, which wasn't too high overall. And then we also had some mathematical errors, which were my fault, and those had to be fixed. And then there was the actual software. We were able to upgrade the software, which meant we could export the data out into tools like Excel, etc., to be able to analyze it a wee bit better. And we also realised that we needed to measure net internal floor area, because if you have a greater number of floors, you obviously have a greater number of staircase area. So it's the net internal floor area that you really need to bring into the equation. So once that had been done, and we had a couple of advantages. One, you could see here from this slide, we now had the tools to analyse the information in the Revit software and the Dynamo, but we also were able to bring the data out into the likes of Excel and then start to look at it in data analytics terms. What's the mean? What's the average? What's the maximum? What's the minimum? And we were able to compare some of the solutions to the current solution, which we then had, because we could program it in and say, well, it was costing for the fabric X amount of pounds, and what was the saving in the, say for example, the lowest cost option, say with a 3-story, or what was the saving on a lowest cost option with a 4-story. And you can see, again, what we were able to find out was, now that the algorithms have been corrected, the number of floors still had an influence, but they weren't just as significant on the cost. There were other things to be taken into consideration. And then the thing that's important with all of this as well is that it's presenting solutions, but we're only looking at 3 things that we're optimizing. We weren't, for example, looking at car parking. So some of these solutions that may well have been slightly lower cost may have been rubbish in terms of car parking, etc. So it's very much a sort of a test of this software to see, increase our awareness of it, increase the awareness of it within the supply chain, and maybe broader within the industry. Then we ran a sort of a final run on that study, and again we found that there was a cost, but this time we ran it with percentage glazing being varied, and we could see that the percentage glazing was actually not directly impacting on the cost. So at least in this study, the number of floors was still significant, but it wasn't just a totally critical factor. The second one then I wanted to show you was the visual impact. Unfortunately, I can't cover the energy because it's such a topic in itself, and it's its own presentation, so that's why I'm going to move over to the visual impact. This one was a challenge in terms of how do you actually measure this, and what we looked at in the end was the intention here was that the people would see the college and see the new building, and it would have an impact on them. And so we looked at the viewers, which were effectively the pedestrians on both sides of the road and the drivers in the cars. So we picked the midpoint of the road. There's an existing wall on the site, and then what we did was we determined that the amount of building that you would see would obviously impact on the visual impact. So if everything else was equal and all design solutions were of the same material, of the same style, the same colors, etc., then if you could see more of the building, that would have more of a visual impact. And then we also took into account how far away the building was. So if you can see more of a building but it's further away, then obviously that might not be as visually impactful as if you had a smaller amount but up close. And again, ran some of the studies, and which we had would expected was that the closer the building would have come to the road, the more visual impact it would have. And what we did then was we ran the existing design solution against one of the the high impact solution, just to see what that would look like, and we visualized it in using the model, the actual RIBA Stage 2 model. And on the top you have the concept design, and I've deliberately left in some of the the signage that we'll have at the site and the trees, etc. And then what you have in the lower part is the higher visual impact solution. And you can see, obviously, if you were walking past that site on the road, there's no doubt the lower one. But one of the challenges we found was that it's nearly having a scoring, because it's subjective. So what you really need to do is you've got your figures in terms of area, but you need to map those into some sort of a scoring matrix. And that might be, say, for example, 1 to 5 or 1 to 10. So our lessons learned, well, the first thing is the software we found to be complex. You are programming, and you also have to be mathematical in nature, and the client needs to be mathematical in nature. The second thing is the updated software that you could export the data is very useful. And then probably the most important thing, which I'm going to come again to this, is the idea that the client would produce a space matrix with tolerances rather than some sort of schedule of accommodation. For cost consultants, I think it would be very useful, and it's worth exploring against existing software they have. Because remember, this is all happening at the very early stage, RIBA stage 1, RIBA stage 2. So it's really looking at optimizing in a sort of a sense. It's something that, in my experience, we don't do. We tend to build buildings that if we hit a certain minimum or cost, as long as we're below that cost, we'll build it. But if anybody has come from a housing background, you tended to not just build once you hit an X amount of houses on a site. You actually try to get as many houses on the site as you could, or you try to get the maximum return on the site, so you would be optimizing it. And you generally might not see that to the same extent in some of the other building types. Include net internal floor area was another lesson learned. And then from a visual impact, I think the important bit of this was I felt at the end that we could measure the unmeasurable. And in our campuses, one of the important things is the visual connectivity. For example, in rooms, that we can see into rooms, so we can see an ICT suite from the corridor, or we can see into other rooms. And some of our more successful buildings have visual interconnectivity between spaces. And you can now measure that with these tools. So you could give your building a scoring in terms of its interconnectivity between spaces, and know if the spaces are going to feel much better when you're in them. And then finally, the scoring has to be subjective. So I know a lot of speakers have finished with a quote, but I'm going to finish with this slide. And it's really, if I think we want the designers and the supply chain to engage with this idea of optimizing designs before they determine a concept, then I think the clients need to give over data, and they need to be thinking a wee bit like mathematicians and programmers. So what they're doing is they're giving over information with more tolerance, for example. So you're not saying, here is our schedule of accommodation from the business case, and here's a large balance. What you would be saying to them is, here is our actual space register with an adjacency matrix, and then on top of that, we're going to give you minimum critical space dimensions as well as maximum sort of tolerances. And I think once you start to give them, and that you're giving to them understanding what you want optimized, and then giving them some sort of range for that optimization. So for example, you might say, well, if we were doing this again, we might say, well, we want car parking optimized, we want the visual impact, we want the energy, we want the cost. So you may have a number of optimizations. And one of the other things, I know I haven't mentioned the energy here, but we are, from our point of view, we're now looking at saying how we might apply that at our existing buildings, and how we might apply it for energy, and getting specifically into that in terms of upgrading and meeting our carbon zero targets. So hopefully you have a slightly, if you haven't any knowledge of generative design, that'll give you some sort of clue on it and some idea about the journey that we're currently on to try and see how it might benefit us as a client. Thank you.